Youth is very important for us to be in the circle of Western colleagues, scientific colleagues. So thank you again. Okay, this very work is about some mathematical models, how we can measure the quality and heterogeneity of enrollment in programs. We choose especially the priority subject of Unified State Exam profile mathematics, but this might be absolutely biology, etc. And a few years ago, before pandemic, I gave this talk concerning this heterogeneity. So, but still I will tell more. And then now we constructed the model of quality. Let me go further. These are the sources of data, and to evaluate the heterogeneity, we use a sample of 12 universities, more or less uniformly distributed. But again, you see, it can be done for all 700 or 800 universities in Russia or any other country. So these are the general characteristic of universities. We use the data from 2015, to 2020. There are still not all data concerning 21, and naturally there is no data concerning the 22. And we have this large group of different specialties, different programs in physics and mathematics sciences, computer science, and economics and management. These are groups which are based on the enrollment exam, Unified Statement Exam, which is called profile mathematics. Now, let's first switch to heterogeneity. The idea, these are the works which try to evaluate the heterogeneity, for instance, by standard deviation, or about they talk about the selectivity of higher education institutions, use Gini coefficients, multi-D graphs, but we suggested a bit different model. It was published a few years ago. The idea is the following. You see, we have this Unified State Exam, and for each university, we can construct this very interval of minimal level of Unified State Exam and maximal level for this very university. And so we can construct this very system of the grades on the x-axis. We can see here the intervals for 5 universities and construct this very binary relation. This is the adjacency matrix of this for these 5 universities. In fact, we did it for many universities. And then if we have an idea of ideal interval order for this very system, then we can evaluate the distance between the real interval order and ideal interval order. And the question is only, this is the Hamming distance to compare this very two interval orders. I will not go to mathematics, but the idea is very simple. You see, we have real interval order, we have ideal interval order, and for instance, just to give you an idea, for instance, ideal might be without x4, for instance, from 80 to 95. This is the first level, 50 to 70 for the second level, and third level, and that's all. Somebody might say that this is the ideal, for instance. And then we should construct the distance to which extent our real system is far from the ideal system. Okay, so that is the idea of how these ideal systems can be, first of all, how we construct this ideal system. Top 10% of universities would talk to specialists in higher education I'm a mathematician, you see, and they said that it should be 10% of universities with average level of entrance grades not below 75. 70% of universities, they are strong professional universities for regional labor markets. The grades should be between 65 and 74, and more, you see, technically, let's say, oriented undergrad programs in about 20% of universities with the grades not below 55. Then we have these ideal universities. We have a real universities which we can evaluate. And then for this very artificial data, we can evaluate, for instance, these are our grades. You see, these are the mean standard deviations and the count of this number of universities. But then we can apply this very idea to our universities. I'm sorry, we didn't translate it. We have, in fact, somewhere translation, but these are universities, top 12 universities, let's say. Okay, and we considered two models. I will not go too far to inside of these models. Consider these equidistant interval boundaries for 2018, for 2019 and 2020. That is what we obtain, that we have 4 classes of universities. These are their intervals concerning these classes, and then evaluate this very right and left scale and compare it with this ideal system. And we got for 2018, it is rather far. In 2019, it was 0.28, and in 2020, it was 0.26, which is rather far away from really the ideal system. Okay, so we apply also this very analysis when we got these classes by k-means clustering on the average date of enrollment exams, and get the same, but a bit more, but it is not too high. So we can say that heterogeneity of the system is rather high. It will be interesting to compare, for instance, this heterogeneity of, in this very sense, from Russia, for instance, in Russia and in Italy, for instance, or in Britain, to understand what is going on. And this is a very new model, and the idea of this very new model, it is again, you see, we have this unified state exam. Using this very data, we will be able to construct the general idea of the quality of enrollment. Again, we took data based on the profile mathematics. And the first very unusual and very really surprising result was that, look over here, from 2015, it dropped down. You see, was rather low, and then for last, from 2018 to 2020, jumped up rather seriously. This is a histogram of average scores for admission in physics, and this is a formula. The idea is very simple. You see, we try to evaluate the share of the universities with corresponding grades. You see, in this whole system, and L is the how can I say, this very level of grades below which you cannot be admitted to the university. We have this very results for physics and mathematics, and here we have two graphs. The first graph is the so-called tuition-based system, and this is the state finance system. Here, people should pay for their education. In universities, this very graph, it is for people who were paid themselves. For computer science and mathematics, you can see, again, you see rather, it is interesting that the quality is different. And here is economics and management. It's called mathematics, but economics and management gives us this very data, this very result. And for selected universities, you see, well, for few selected universities, we have very different results concerning this very quality of education. So, and few words about this very quality of education. It was, for me at least, you see, it was rather surprising, this very picture when quality of education jumped rather seriously. And I did not understand why it is the case. And there was an idea to evaluate the complexity, let's say, the level of exam questions, the complexity of exam questions for years. And we could not do it, but we hopefully will do it in the future. Because this very data, it is possible to find them in the Ministry of Education. And I hope maybe we will be able to explain, well, I have a hypothesis, but this is really hypothesis that this jump in the level of enrollment was because of the level of entrance exams were a bit, let's say, decreased. Maybe. You see, it's not a conclusion, but it's as a hypothesis. I hope to understand what is going on. We will understand what is going on, and next year's in the conference, we will be glad to present these very results. Thank you very much, and I am ready to answer questions. Maybe I was too fast, but if there are some questions, I am ready to explain and respond.